Hi guys, this is Mr. Urrego, and we're gonna solve a let's write this first. So we're gonna solve a trigonometric equation. Let's call this theta. My angle is gonna be angle theta, so it's 2 cosine squared of theta plus sine theta minus 1 equals 0. So I'm gonna find the value of my angle theta. Okay, the angle theta is between 0 and 2 pi. Okay, so that's my angle between 0 and 2 pi. So I have this. Okay, so first things first, I have 2 cosine squared theta plus sine theta minus 1 equals 0. Okay, I have some kind of trigonometric equation, but I have cosine and sine. I can't have that. I need to have either the cosines or I need to have the sines, one of the two. So in our case, I see that I have a cosine square and my sine is not to the second power, so I want to have my equation in terms of sine because my sine is not to the second power. Okay, how can I turn cosine in terms of sine? Here's the magic trick. So I'm going to use my Pythagorean identity, which is sine squared of theta plus cosine squared of theta equals 1. This is the Pythagorean identity. I'm going to use this to get rid of that cosine and turn it into a sine. Again, I want to get rid of that cosine squared, turn it into a sine. So here, let's leave the cosine by itself. So I'm going to do minus sine squared of theta on both sides. Okay, the sine cancels and I have cosine squared of theta equals to 1 minus sine squared of theta. And the cosine is by itself. So I'm going to substitute this here. So let's go. So we have 2 times this times cosine. But my cosine is 1 minus sine squared of theta. 1 minus sine squared of theta. Okay. Close parenthesis. I replace the cosine. Sine theta minus 1 equals 0. Now everything is in terms of sine. Now I just algebra. 2 times 1 is 2. 2 times negative 1 is negative 2 sine squared theta plus sine of theta minus 1 equals 0. Let's organize this. Let's combine the 2 and the negative 1. So I have negative 2 sine square of theta. Okay, this is nothing by the way. All right, so negative 2 sine square of theta plus sine theta, and 2 minus 1 is positive 1. All right, we're organizing. I don't want to have my leading coefficient with the sine squared negative, so I'm going to divide all this by negative 1 on both sides. So negative negative is going to turn into 2 sine squared theta. Positive negative turns into negative sine theta. Positive divided by negative is going to give me negative 1, and 0 divided by negative 1 is 0. All right, looks way better. Okay, I just organized my trinomial. All that trick was to turn into the cosine into sine. Now I have a trinomial. I got to factor this trinomial. I'm going to use a little trick of substitution, and I'm going to say, oh, let's call sine theta. Let's call that x. All right, so I'm going to replace this in my trinomial. So let's go. So I have 2 sine squared theta, but sine theta is x. That means 2x squared minus sine theta. Oh, but my sine theta is x. So minus x minus 1 equals 0. Okay, now I have this. Now I have my trinomial. It's just algebra. Let's factor this. Okay, I use grouping to factor this. How do I do grouping? I take my first term. Oops, no, let's do blue. My first term, my leading coefficient times my constant, and that's 2 times negative 1 is negative 2. So my product is negative 2. My sum is the value in front of the x. In this case is negative 1. I need two numbers that multiply get -2, but when I add, I -1. There's not too many choices. 2 times 1 is 2. But I need my product to be negative and my sum to be negative. Therefore, the bigger number has to be negative. -2 times 1 is -2. And if I plug these same numbers here, -2 and 1, it'll give me -1. Excellent. Let's keep going here on the right side. All right, I'm going to bring that trinomial. 2x squared minus x minus 1 equals 0. And I'm going to break the middle value. The middle value, okay, this negative x, I'm going to turn that into -2x plus 1. That's where I use these two values, -2 and 1. -2x plus 1x. Okay, I bring down the first term, which is 2x squared, and I bring down the last term, which is -1 equals 0. Now I have 1, 2, 3, 4 terms. Now I solve this by grouping. Let's take the first two. Okay, my common factor, well, the first two and the last two. My common factor here is 2. The 2 is in both. And the x, I use the x with the lowest exponent, which is the x. So the first power. I take my first term, 2x squared divided by 2x. The 2's cancel. X squared divided by x gives me an x. Minus 2x divided by 2x is the same thing. It's equal to 1. 2x divided by 2x equals 1. Next, I see in my second parenthesis, technically there's nothing common. If there's nothing in common, I take a plus 1 out of it, because the positive 1 is not going to affect anything. And I open my parenthesis. 1x divided by 1 is x. -1 divided by 1 is -1 equals to 0. When I'm doing grouping, the two parentheses have to be the same. If they're the same, that means I'm doing it right. So at this point, I take that common parenthesis as a common factor. Whatever's on the outside of those two parentheses, whatever's on the outside is going to come on the second parenthesis. And I'm done with my factoring. That was just the factoring. Okay, let's solve for x. Now, every single term, every single factor, I'll make it equal to 0. Because remember, I have my equation, or my two factors in this case, equals to 0. All right? I'll do the same thing with the second factor, which is 2x plus 1. And now, let's solve for x. Here, I do plus 1, x equals 1, right? And the second one, -1, cancels out. 2x equals -1, divided by 2, x equals -1/2. As soon as I have the x by itself, it's time to go back to the original. So now I gotta go back to the original. Remember, what's my original? Sine of x equals x. So instead of the x, I'm going to write sine of theta, equals to 1. And this is what I'm solving. Now I'm ready to find the values of theta. Here, instead of this, I'm going to write sine of theta equals to -1/2. Okay. Now, what are the angles that I'm looking for? Sine of theta equals 1. This is a quadrantal angle. Okay, where is this located? So let's draw a unit circle for this real quick. Unit circle. Remember that every point, this is 1, 0. This is 0, 1. I'm sorry, the other side is -1, 0. I hope you get the idea. X is your cosine, y is your sine. Y, here we go. So y equals 1. This angle is 90 degrees, which is the same as, because I'm doing it in terms of pi radians, 90 degrees is the same as pi over 2. So my angle here, my first answer is pi over 2. All right, I gotta do the same process with sine theta equals to negative 1/2. For sine theta equals negative 1/2, I'll be using a special right triangle, the 30, 60, 90. 30, across the 30 is the 1/2. So I'm thinking I need to use the 30-degree angle, which is pi over 6. Okay? So, again, my 30, 60, 90, this is my 30-degree. Across my 30, this length is 1/2. That means my angle is 30, which is pi over 6. This is going to be my reference angle. My sine is negative. My sine is negative on Q3 and Q4. Because why? Because it's the y value. Y is negative on the Q3 and Q4. My reference angle is 30, so I got to draw right there the 30, or pi over 6 and pi over 6. So this is pi over 6, this is pi over 6. I got to find my angles. Remember, my angles are always from the origin. So this angle, okay, the top is pi, which is 6 pi over 6. All right, 6 pi over 6 plus 1 pi over 6. This angle here gives me 7 pi over 6, and that's one of my answers. Let's do the second one. All the way to here. If I have 6 pi over 6 on the top and 6 pi over 6 on the bottom, minus 1, so 6 and 6 is 12 minus 1, that angle is 11 pi over 6. Therefore, my answers, what are my answers? Pi over 2, 7 pi over 6, 11 pi over 6. All right? And that should be it. We review everything in terms of the equations, how to find the reference angle, how to locate the quadrant. Okay? All right. Thank you very much for watching.